Evaluate the infinite series by identifying it as the value of an integral of a geometric series. So they want us to figure out what's the sum of this. Turns out there's the answer pi over 4. How do we know it? I'm going to follow their hint. Write the integral 0 to 1 where this is f, which is equal to that, and you'll have it. Okay, now why is that hint true? Let me just do their hint first. Get the answer, then I'll talk about why the hint is true. So if I say, okay, f of x is 1 over 1 plus x squared, that's what they're saying, f of x is 1 over 1 plus x squared. And then I integrate from 0 to 1 f of t dt. It does f of t dt, f of x. Is that confusing for you? I remember back when I was a calc student thinking, can they change t? I thought it was x. Remember, this is just holding a spot. Once I got that straight, it helped me a lot. You just think about it that way. It's just f of whatever. The X, the T, you call it Joe, whatever. It's just holding. It's like the holes in a toaster. It's just the blanks where you insert whatever. It's just a dummy variable, we call it. It's just holding a spot. This and this are just holding a spot. So don't let that bug you like it used to kind of bug me. They can put any letter. It's no different than if you say this. These are exactly the same. They mean the same. Not TT. You can't change the letter. Whatever, whatever's here must be there. So those are the same thing. Those are exactly the same thing. This is just holding a spot. That's all it's doing. Anyway, all right. So whatever they want to call it, you're just going to integrate that function. And so you're going to integrate. In fact, let's just stick in the function. You're going to integrate 1 over 1 plus x squared dx. Okay, so how do you integrate that? What's the antiderivative of that? I don't know if you remember. It's inverse tangent. Inverse tangent. And we're evaluating it between 0 and 1. So 1 over 1 plus x squared, the antiderivative is inverse tangent. So you gotta remember that. I know we've had a lot of antiderivative formulas, but there's a particular one. 1 over 1 plus x squared, that's, if you take the derivative, do it that way. Right? Remember, if you have inverse tangent, the derivative is 1 over 1 plus x squared, and so the anti goes back. Okay. So anyway, so what? So that means plug in your 1, tangent inverse of 1 minus tangent inverse of 0. Okay, now what's tangent inverse of 1? Tangent inverse of 0. Let's go to Desmos if you don't remember. It's no problem. Desmos knows. Desmos always knows. Okay, so I'm going to go tangent inverse of 1. So function tangent inverse of 1. Gives me that. Oh, it's giving me radians. Degrees. So it's degrees. Yeah, so that's great. That's great. 45 degrees. Yeah. Now you could go here. Let me go to the other Desmos. Desmos graphing, That'll probably be better. So I can get there. Hello, iPad. It's not doing anything. There we go. It's having a little bit of trouble today. Desmos graphing. Tangent errors, come on, baby. There you go. You're doing so much better. Let's see. Okay, let's go to tangent inverse. Functions. There it is. Tangent inverse. Put in 1. Yeah, well, it just gives me the radians. That could be confusing. I can see what that'd be confusing. There's the radians. That is pi over 4. We saw it. We saw it in the Desmos. I guess I should have just stuck with this. 45 degrees. That's pi over 4. So pi over 4. Remember that? 45 degrees is pi over 4. Because remember, pi is 180 degrees. 180 over 4 is 45 degrees. So minus tangent inverse of 0, 0. You can check it on Desmos. This is pi over 4. And that is our answer. Now, question I would have if I was you. I was like, okay, I get it. I did the hint, did the trick, did the integral. It's a little tricky one, remember, and 1 over 1 plus x squared, the antiderivative is tangent inverse, and also tangent inverse of 1 is pi over 4. Okay, why? Why is that true though? Well, you can tell because if you take this formula, they're saying this formula right here is first off, why is that 1 over 1 plus x squared? Well, here, let me do this for you. Let me give you this is all now we're done with the problem. Here's the reasons. First off, why is this formula the sum minus 1 to the n x to the 2n. Why does it equal that? Well, remember, this is the one we always use all the time from the notes. This is the beginning of the chapter 6 power series notes. There's the main formula we use. 1 over 1 minus x was The sum of x to the n. Know that one. Know that one like the back of your hand. That's the main one. 1 over 1 minus x is the sum of x to the n. Okay, so what? That means, remember, this is like a blank, right? You can plug anything in here, and it shows up there. Okay, so what? So that means if you have the sum of anything to the nth power, you can plug in. Well, this isn't something in the power, right? But we can rewrite it. This is the sum of minus 1 to the n x squared to the n. Again, both to the nth power. Just keep it in the yellow here, whatever. And this will be the sum of minus x squared to the n. Or here, I'll go minus 1 times. Is that easier for you? That's saying right, that minus 1, boom, boom. The n could go back to both. Now, why did I do that? That's all rewrite. Why did I rewrite it like that? Because now I've made it look like this. That's what we do in math and science. When they give us formula, they give us a formula like this that we want to use. And all this is just proof. You could stop watching the video. We're done with the problem, but I hope you're interested in seeing why is this true. Okay? Because the formula, the basic formula we have for the geometric series from the notes is that you have the sum of anything to the nth power, it's 1 over 1 minus that thing. So I had to rewrite this so it's one, it's stuff to the n power. It's stuff to the n power. Now, as soon as you got that, then you can use this form. That's going to equal 1 over 1 minus that stuff, which is minus 1 times x squared to the n, right? Which is what? 1 over 1. Um, Now, what is minus what's going to be um, minus 1 to the n x to the 2n, right? Like that. Or actually, we're going backwards here. I'm trying to show this is 1 over 1 plus x squared. So, I'm getting a little bit lost in my own work. Oh, wait, what am I doing? I'm being so dumb. Sorry. This formula says it's 1 over 1 minus that stuff, not the n. Da da da, dum dum dum. Just like that, right? That's what this formula is. I got to read the formula. It says if you have the sum of anything to the nth, it's 1 over 1 minus that thing. Just that thing, not the nth power part, just that plug-in part. So it's just that, which is 1 over what? 1 plus x squared. Boom. Boom. That proves it. The sum of this is 1 over 1 plus x. That's where they got that from. Now you think, yeah, okay, I see where they got that from. But why is the integral of that work? Because now, last little bit of proof here. The last proof is if you integrate the f, meaning this, minus 1 to the n x, if you integrate that, you add 1. Well, here, the minus 1 doesn't matter. Just pull that to the front. It's minus 1. It's just a constant number, right? Um, and you add 1 to the power, what are you going to get? X to the 2n plus 1 over 2n plus 1, aren't you? If you integrate that. But then you're going to go between 0 and 1. So you're going to plug in a 1 there. So that's going to go away. So it's going to be minus 1 to the n over 2n plus 1. It's that. All right. You see all that? So we proved that this is the integral of this, and this is this. So we proved it's all true. So there we go.